Hello, my name is Sean Nelson. I'm a student at the University of Florida studying electrical engineering in a class called EEL 6825 Pattern Recognition. And this is my presentation on optical character recognition, or OCR, with neural networks. You might notice that my current setup has 3 screens. So this is a non-traditional resolution for YouTube. I highly encourage you to if you can, stream this video on high definition so you can see all the code and stuff I'm going to go over. Otherwise, it's going to be a little bit fuzzy. But at any rate, so here in the center is my PowerPoint presentation that I'd like to review with you. So moving right along, some of the topics I'd like to cover. First one is what optical character recognition is, followed by pattern classification, neural networks, my project and my approach, demonstration of my code, the results, and then a summary and conclusions. So optical character recognition is the identification of characters by a computer. Essentially, it allows for the conversion of images to text, which is very handy. It allows them to be searchable, for example. It allows for archiving, machine intelligence, etc. So it's a very useful, very powerful tool. So a little bit about pattern classification. In pattern classification, there are 3 basic steps. The first one is pre-processing, followed by feature extraction, and then it goes into classification. So this is a standard structure for all classifiers, and I'll dive into a little bit more detail when we go through my code. So what is a neural network? Well, a neural network is a algorithm essentially for learning how to classify items. So it's a type of classifier, and the way it works is that there's a number of input layers, which are essentially the number of different characteristics that are available. And then they go to the next layer, which is called the hidden layer. And in this layer, there's a number of neurons that actually take this data and weight it. And then this is actually what's called a feed-forward neural network, which means that after it applies a certain weight to this input, it forwards it to the output layer, which eventually also combines and weighs it and then puts it as the output. So the entire concept behind a neural network is that it will, once trained correctly, it will eliminate the connections that do not contribute to an ideal solution. So this can be very powerful because what it means is that it allows for machine learning. So this is the approach. This is the kind of classifier I chose to study in my project. So a little bit about my approach. So this is the flow diagram for how my project operated. So starting here in the center, you can see what I started with was existing feature database from a group called UCI, and this database went into what I call the classifier training. And so in classifier training, I listed a number of different algorithms. I actually went through a whole pile of algorithms, all the ones that MATLAB had, and then came down to these algorithms here to evaluate in this project. So you can see there's a handful of those. So the way this works is that the classifier, actually it starts over here really, where there's a design that's started, which is the classifier network, and then this starts with a number of different hidden layers. So to start with, I started with 10. So this classifier design would then roll into the classifier training combined with the various training algorithms one at a time, would go into classifier evaluation where it produced something called a confusion matrix, which is essentially a matrix that has all the targets and the outputs and lists how many it correctly classified and how many it did not. And so what I did is I ran through this loop here on the left a whole pile of times, and each time you run it, it produces a new classification matrix. And then when I was done with this, I produced a graph that charted the overall confusion versus the number of neurons, the number in the hidden layer. And then I did this for each one of these algorithms, training algorithms. So, however, I didn't feel that was enough for some reason. So I also on my own attempted to build my own database. So what this required was pre-processing and feature extraction. So you can see here in PowerPoint, I actually created a number of different letters using various fonts, and this was used to go into pre-processing, where I extracted an image that contained all the different characters in black and white, which allowed MATLAB to manipulate it easier. And then this went into feature extraction, where it produced a giant matrix of all the various features that I wanted to analyze. So I use this. So again, here's the pre-processing here, feature extraction, then it goes into classifier training. So this batch training algorithm was the first one to start with, and then I went through all these other algorithms. So again, just like before with the previous database, looped through this a pile of times, produced a bunch of these confusion matrices, and then produced graphs for each matrix, for each training algorithm rather. And then, because I felt that that still wasn't enough, I also did this with additional features added. I actually found another gentleman who had done some code of his own to extract additional features that MATLAB didn't have built into it. So I thought maybe that this could help improve the performance of my neural networks by adding more features. And so I also added this capability to it, and also produced and also ran through this again. So essentially there's three different databases that were used for a total of 10 different classifier designs for a total of 7 different training algorithms. So a huge pile of data, a whole bunch of things to go through. So it was very interesting. So next I'd like to go into my code demonstration, which is going to be a dumbed down version of what the overall project was. The overall execution of this code took several hours. So but to give you a run, I use MATLAB version 8.1. This is a student copy that's licensed to me, and in there's two main toolboxes that are required. One is the image processing toolbox, and the other one is the neural network toolbox. So over here on my left screen, you can see this is the execution window for MATLAB, and then over here on the right is the script editor. And so here on the left part of my right screen is my main routine. So what I'm going to do is go ahead and start executing it. So I'm going to hit F5, and what you're going to see is a whole pile of graphs pop up, and then I'll start walking you through it. So what you see here on the left, let me move this window over so you can see the graphs. So what you see over here on the execution window of MATLAB is the training case, which is just one case, in my case 17, and then the number of hidden layers it's processing. So right now this is 10, this is 20, this is 30, and you can see every time this iterates here on the left screen, a new confusion matrix pops up here in the center screen. And you can see here in the GUI for the neural network training that it's going through a number of different iterations to process and to train, validate, and then finally test each neural network. And so this is continuing to execute. It's up to 60. So coming over here on the right, I just want to walk you through a little bit of my code. So starting here in my main routine, we start by reading in the image, which is on the previous PowerPoint, and displaying it as the original image. And then it goes into this routine called the pre-processing routine. So if I jump over to pre-processing, no, I'm sorry, no it doesn't. Okay, it converts it to grayscale, and then from there it goes to threshold, and then from there it shows the figure. So that's all the pre-processing that's conducted. And then it actually also inverts it. And inversion is actually very important because this allows me to actually grab the various characters for other routines. So, all right, so it's finished executing. You can see here that it only took 93 seconds. Again, to run through the entire script took several hours, so I'm not going to do that for this demo. But I did want to show you the rest of this code. So I talked a little bit earlier. So here's the original image, and then here's the grayscale image, and then here's the thresholded image, which is again part of the pre-processing routine here. So this is grayscale, I'm sorry, this is threshold, and then inverted. And then, so this jumps over to routine now called feature extraction. So if we go to feature extraction here on the far right, this routine uses a built-in MATLAB function called region props, which automatically takes each letter here and pulls out a whole pile of characteristics. I also actually plotted red dots on the center of each of these, and the reason for this is initially when I started doing this I had problems because the thresholding caused some of these letters to be degraded, so I had to eliminate some of the fonts that I originally wanted to use. But at any rate, this allowed me to verify that they were all processed correctly. So moving right along, so after the feature extraction routine, this produced two matrices, one called alpha inputs, one called alpha targets, and then this was fed into the neural network. So this calls a routine called NN classifiers. So if I jump to that, that's this guy over here, and this is the meat of the project. This one goes through a giant loop for all the different layers. So we've got 10 to 100, which goes through, there's also a training case which is passed to this, which again was 17. So training case 17 was train RP, which is rprop backpropagation training algorithm. So these three guys here actually set up how much of the data percentage-wise I use for training, validation, and testing. So this runs through here, and for each iteration it runs this, and you'll see here that I said use GPUs and yes, and the reason for that is, again, I had problems using my CPU, which is a little bit surprising since it's an i7 975, which runs at 3.33 gigahertz, and I have got gobs of RAM too. There's 12 gigabytes of DDR3 RAM in this machine, but it still really struggled. So I had to swap it over to the GPUs, which are NVIDIA GeForce GTX 480s. I have two of them, and they're liquid cooled, so they're much better at this. So it's nice that they have this built into this function that allows you to do that. But anyway, so moving right along, this produces the outputs, and eventually I produce a number called the confusion matrix, which I then pass, and I also produce this figure here for each one, which is each one of these confusion matrices. So again, if we zoom in here, you'll see down at the bottom it gives you two numbers. These are 26 by 26, so there's 26 characters, and then the green down the center is correctly identified, red is not correctly identified, gray is summary, and blue is a summary of the entire thing. So it produces one of these per run, and then this graph here is actually the summary of all those runs. So you can see here, and this is the fraction of samples misclassified. So you can see here in this example that I'm showing you, this classifier did terribly. It got fewer than around 10% was correct, and then the rest were awful, regardless of what hidden layer, essentially. So that wasn't very good execution. So, but that's a demonstration of my code. Again, it was very extensive, and in my final report, I actually have piles of data. But so to conclude, though, what this study found out is that the best combination of the way this experiment was performed is the UCI character feature data set. Again, this is a standard data set that I pulled from a website that's cited in my code. And then there's the one that produced the best results was the one with 90 hidden layers. Used this rprop backpropagation training algorithm, or train RP in MATLAB. And then the resulting performance here was actually pretty good. It had less than 15% misidentified, so that's not too terrible for this level of algorithm. So that concludes my presentation on my code. If you have any questions, please feel free to leave comments below, and I'll make sure to get to them. Thank you very much.